physics review videos, Unit 1 science skills, topic measurement, and conversions. This is Mr. Anderson. It's probably one of the first review videos you're taking a look at, and we put these together thinking about what skills have students forgot about, failed to learn, or have a tough time with. So in the first unit, what I really thought was a problem, what really grinds my gears all year that kids don't pick up on, is basic measurement. And regarding basic measurement, many of us have a problem just choosing the correct side of a meter stick or ruler when making measurements. Big problem when it comes to lab data, because if you're not measuring with the correct unit of measure, you're never going to get the correct answer. So let's take a look at a ruler here. There's two sides. Many times they're not marked in an easy way that we can pick out what's inches and what's centimeters. So I want to go over this quickly. Top part's already marked millimeters, so we know this is the metric side. If it is not marked this way, the easy way to check is count the lines between two whole number measures. There are 10 lines here. Metric is base 10. The other side is the imperial system. If you look at it, let's look between 1 and 2, there are 8 measurements, because the imperial system has no rhyme or reason to how its units are broken up. There could be 8, there could be 4, there's 12 inches in a foot, 5,280 feet in a mile, 3 feet in a yard. There is no standard system. In science, we use metric because it is base 10. We are never using the bottom part of this ruler. Stop using imperial. Just don't use it. Look at it. That inch is big. It's about the length of the tip of your finger. If you're measuring with something like that in a science classroom, stop. Grinds my gears. Stop. Moving on from that, we need to review basic conversions. These basic conversions you did in chemistry all year long, be it a mole, 3.50 milligrams to moles of, let's say it's carbon. You set up 3.50 milligrams. Your first conversion was milligrams to grams. 1,000 milligrams is 1 gram. And then your other conversion was grams to moles. And since you were such great chemistry students, you remember that this is the molar mass. 1 mole, 12.01 grams. And you would finish up that conversion. We're using the same skill in physics with our metric measurements. Metric prefixes you've seen before. Our big ones this year will be kilo, base, which is nothing, deci, not used too often, but we will use centi, milli, and then second semester micro and nano. One way to do these, let's say we want to go from 35.5 centimeters. You measured on your meter stick, and you want to go to meters because that's what you need for an equation. Look at the powers. Centi is 10 to the negative second. Meter has no prefix. It is base. That's meter, liter, second. So that is 10 to the 0. They are 2 powers of 10 different. So when you set this up, 35.5 centimeters, you know centimeters goes on the bottom. Meters without anything on the front goes on the top. That's 2 powers of 10. The smaller one gets that. 10 to the second, which means 100. Centi is 100. This would get the 1. 35.5 divided by 100, you would get 0.355 unit meters. What really grinds my gears is when I start seeing this. No math teacher taught you that. That is wrong. That is not a number. Just stop doing it. This works for all the measurements. Second semester, you will be seeing nanometers. So let's say 7.8 nanometers. We need to turn into, let's say, centimeters for a problem. So 7.8 nanometers nanometers on the bottom, centimeters on the top. Now we need to know what numbers go on these lines. Centi is 10 to the negative second. Nano is 10 to the negative ninth. That's 7 powers of 10 apart. Centi is larger, so it gets the 1. Nano is smaller, so it gets 10 to the 7th. Units cancel. You could really just write this as 7.8 times 10 to the negative 7th centimeters. That'd be a correct answer. One other way to look at these, if you're really having a difficult time, you measure something in millimeters. Let's say 32.8 millimeters, and the problem needs it in base unit meters. You can just use this power and plug it into your calculator. Milli means 10 to the negative third. So if you want to plug this into your calculator as 32.8 times 10 to the negative third meters, that will work. This is not good for an answer, but this could work in your calculator. Let's look at another one. If they give us 420, let's say kiloliters, and we need milliliters for some reason, we could look at the powers here. This is 10 to the third. This is 10 to the negative third, so that's 6 powers of 10 difference. It's going to be getting larger, so we could set up 420 kiloliters, milliliters, kiloliters, 1, 10 to the 6th. So we would get in our calculator 4.20 times 10 to the 8th milliliters. So those are the basic metric conversions you'll be seeing all year long. There's also some that you're going to see that are a bit more complicated, so really listen up. Really listen up. You'll start seeing rate conversions in physics. Here's an example. What if I wanted to go from 45 centimeters per second to meters per second? Keep your top bottom. Don't do one of those slash. That's not going to help you out. Same system, 45 centimeters per second. We're just wanting to change the centimeters, so leave the seconds alone. 1 10 to the second, you would get 0.45 meters per second. They'll get a little bit more complicated. What if we're going from 87 miles per hour, and we want meters per second? You're going to see this one all the time, constantly. So if there's anything you listen to, listen right now. Set up your 87 miles per hour. There's a basic conversion. 1610 meters equals 1 mile. It's going to be your good friend. So we're going to turn our miles into meters. And then we are going to turn our hours. Notice where hours have to go. Hours on the bottom, so hours has to cancel on the top in seconds. 3,600 seconds equals 1 hour. That's one of your big conversions you are going to see over and over this year. 87 times 1610, enter, divided by 3,600, enter. If you paid attention, good, we should be fine for the rest of the year. If not, restart the problems. Let's do these all over again. Watch the video over and over and over again. Come on. You don't want to be that student asking the same question or getting the same question wrong on every quiz. So let's figure out A, how to measure, B, how to do conversions, and then we can move on and do some real physics later on.